Hi, this is Michael Pfeifer, Principal Consultant and Trainer at Industrial Metallurgists, and this is the Metals Conversations podcast. This podcast episode is a tribute to steel metallurgy knowledge. So the human civilization has been using iron since about the 12th century BC and has been using steel for at least the past 2,000 years. And in the past 100 years or so, our knowledge of steel metallurgy has exploded. And this also applies just to metallurgy in general. So for metallurgy in general, we're concerned about getting the properties we want in any particular piece of metal. This could be strength, ductility, corrosion resistance, fatigue resistance, and a wide variety of other properties. Properties depends on a metal's composition and its microscopic structures within the metal. Microscopic structures include grains and phases and dislocations. We can't see these things with the naked eye, but they're very important to the properties of a metal. And it's the same thing as the analogy would be for our bodies. There are all these cellular processes and things going on inside of our bodies that we can't feel, but we know that they're very important to the functioning of our body and for our good health. And the same thing occurs in metals, with all these things going on a microscopic level, and those things affect the properties of a metal. So we can alter the microstructure of a metal through alloying, that is adding different alloying elements to a metal, and also through processing. And processing means mechanical and thermal processes that are used on metals. This could be metal casting, heat treating, cold rolling, forging, welding, and many other processes that are used on metals. All of those different processes influence the microscopic structures present in metals, which then influences the properties of metals. And finally, properties include mechanical properties, electrical properties, ease of component fabrication and ease of component joining, reliability, cost, and also physical properties. So mechanical properties would be things like strength, hardness, and ductility. Electrical properties would be electrical conductivity. Ease of component fabrication refers to the ability to fabricate a component out of a particular material. Some materials are easier to machine than other materials, or easier to stamp or forge than other materials. And the same thing goes for joining. Some materials are easier to weld than other materials. And so we have to select alloys, or it's important to select alloys that are easy to fabricate and join if we want to keep the costs of a component and of an assembly down. Also, reliability. Different materials have different properties, and we can alter the composition of the microstructure in order to affect fatigue resistance, corrosion resistance, creep resistance, and wear resistance. And then also cost. Different alloys have different costs, and we can use different processes that will result in different properties, but can also influence the cost of a material. So there are a lot of properties that we're concerned with, and we can use composition and microstructure to influence the properties of a metal in order to meet all the different requirements for a particular application. By understanding the effects of alloy composition and mechanical and thermal processing, we can select alloys and processes and control the process in order to get the desired microstructure in the metals and therefore get the desired properties. So the two things, again, that influence the properties are composition and microstructure, and we also use composition and the processing to influence the microstructure. So there are a lot of things going on that help us influence the properties of any metal. We just have to understand those things that influence the properties and control those things so that we can get the properties we need. So for example, in steel, which I'm going to talk about now, carbon strengthens and increases the hardness of steel. In many steels, sulfur and phosphorus are impurities, but they're intentionally added to some steels in order to make them easier to machine, though these elements ruin the weldability of the steel. Adding nickel, chromium, or molybdenum and other elements can alter will alter the steel's response to strengthening heat treatment, making it possible to strengthen large components. Finally, it can add at least 10.5% chromium, which will result in a corrosion-resistant steel, which we call stainless steel. We also understand the effects of mechanical and thermal processes on steel microstructure for any particular alloy composition. Thermal processes include heat treatments such as casting, annealing, normalizing, and quench and tempering. Mechanical treatments include cold rolling, drawing, and stamping. And thermomechanical treatments include hot rolling and forging. All these different mechanical and thermal processes cause changes to the steel microstructure, and those changes result in changes to the steel properties. And by understanding the interaction between the thermal processes and the composition, we can get the desired microstructure in the steel and the resulting properties that we need for any particular application. So our knowledge of steel metallurgy has exploded in the past 100 years. And this knowledge has enabled three things. First of all, it's enabled ultra-high volume steel production processes that are capable of producing plate, sheet, tubing, pipe, bar, and wire. And tons of steel are produced every hour at steel plants all over the world. Our understanding of steel metallurgy enables the high volume production because people understand so well how to automate the processes and how to control the steelmaking processes, both adding the alloying elements to them, as well as controlling the processes for casting the alloy and then rolling it out. And all the heat treatments that go on at the mills, they understand the effects of all of these things. This has enabled the automation that enables high production manufacturing of steel. The final thing I'd like to say about the high volume manufacturing process and steel, the engineering of the manufacturing process, is that it's really amazing how inexpensive steel is. For a basic, let's say ASTM A36 steel that meets certain mechanical and composition requirements, that steel is only 60 cents a pound. Now granted, there are other more complicated steels, but still, the fact that we can get steel over and over again that consistently meet our requirements and at a reasonable cost is pretty amazing. Second, our knowledge of steel metallurgy has enabled engineering a wide range of components with a wide range of properties for a wide range of applications. Steel is an extremely versatile material. We can get a wide variety of strengths and hardnesses. Also steel, we can make a steel that has high strength and also has good machinability, or we can have a steel that has good formability, and then we can take and heat treat it in order to have high strength. And we can add different alloying elements in order to get high corrosion resistance and also high strength. So there's a lot of things we can do to tune a steel to get the properties that we need. Finally, our knowledge of steel metallurgy enables us to quickly solve component failures and quality problems. Because we understand so well the effects of alloy composition and processing, that is different heat treatments or cold working or different shaping processes, and also the effects of different loading conditions on steel, that is the stresses that the steel is exposed to, we can apply that knowledge to figuring out the cause of component failures when components fracture or when they corrode, or when there's a quality problem with material when you're trying to make a component. So we have this tremendous amount of knowledge about steel metallurgy. This knowledge continues to grow, and more alloys and processes are being developed all the time. But for the vast majority of applications, the current knowledge base is sufficient. If you're interested in learning more about steel metallurgy, we have a video that goes into more detail about steel metallurgy fundamentals. Look for the Tribute to Steel Metallurgy Knowledge blog on our website at www.imetllc.com. You'll see the video about the steel metallurgy. Also, we're having a live training event on May 17. You'll learn about common steel microstructures, the basics of common steel heat treatments, the effects of carbon content and heat treating on steel microstructure, and the effects of carbon content and microstructure on steel strength, hardness, and toughness. The information will help people make better decisions about the steels they're using in their products, help them solve problems faster, and just be more familiar with the vocabulary and the terminology used with steel metallurgy, so that when you're having conversations with customers, suppliers, or labs, you'll be able to be better equipped to participate in the conversation and have a productive conversation. That's it. Thanks for listening, and good luck with your metals. Bye.